Good day, grade 10 learners. Welcome to my YouTube channel. I am Sir John Lipernada, and for today's video, I am going to discuss to you one of the integral competencies in Mathematics 10, which is all about patterns and sequences. Before we proceed to our proper discussion, let me enumerate the competencies you must acquire after this lesson. So after going through this lesson, you are expected to first is to illustrate arithmetic and geometric sequence. Next, you are going to determine arithmetic or geometric means and term of an arithmetic or geometric sequence and the sum of the terms of a given arithmetic or geometric sequence. And the last one, after going through this lesson, you are expected to solve problems involving sequences. Before we proceed to our proper discussion, let us have a short realization about this important term in this lesson. So, in almost everything we do, in our daily living, and in everywhere we go, there is one thing that is always there, but most of the times we didn't mind it. That is why we usually becomes disorganized. And what I am talking about is the word sequence. In cooking our meals, there is a sequence of procedures. In washing our clothes, there is also a sequence. In building our homes, there is always a sequence. And in achieving our goals in life, there is always a sequence. And that is how important a sequence is. Okay, let us now define what really the sequence is. So, according to a source, a sequence is a collection of numbers in a specific order. So, take note that we can only consider a collection of numbers a sequence if it is arranged in specific order. Okay, take a look at the representation below. We have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6 until a sub n. Okay, the a sub 1 here will be our first term. A sub 2 is our second term, and a sub n is our nth term. For you to have a clearer understanding on the word sequence, let me show you some examples. For example number 1, we are going to find the next term in the sequence 4, 7, 10, and 13. So what will be the next term after 13? So just by guessing and checking, we can easily find the next term of this sequence. Guessing and checking and finding pattern is just like this one. So we know that our first term here is 4. And the question for you now is, after the first term which is 4, what do you think happened why we had 7 here? And I think, I am assuming that all of you are also saying or also thinking that the reason why we had 7 here is because we added 3 to 4. That is why we have 7. And if we are going to apply it by just assuming that it is the pattern that used in this sequence, so we will have this one. So 4 plus 3 equals 7, and 7 is our second term as is stated here in our sequence. And if we are going to continue this pattern, so we will have, so the second term which is 7 added 3 is 10, and 10 is our third term. And after that, our third term plus 3 again is 13. And 13 is our fourth term. So now, for us to get the next term that we are looking for after the term 13, we are just going to continue this process. So we will have, so the next term in this example will be 16. So why we come up with 16? Because our fourth term is 16 and the pattern that we assume is by adding 3. That is why 13 plus 3 is 16. So that is the term, this is the term that we are looking for after the term 13. And again, the pattern that we apply in this sequence is by adding 3 to the preceding term. We added 3 to 4, that's why we have 7. We added 3 to 7, that is why we have 10. We added 3 to 10, that is why we have 13. And we added 3 to 13, that is why we have 16. Okay, example number 2. Find the next term in the sequence B, E, H, and K. So now we are going to know what is the next term after the letter K. So again, our A sub 1 here, or our first term is B. And I think some of you are also agreeing that the reason why we come up with its next term, which is E, is because we skip two letters. We skip two letters from the first term, which is B. So again, so we assume that we skip the letters C and D. That is why we had our second term, which is E. And now, since we know that by skipping two letters is our pattern, then let us try. Let us try if that pattern will satisfy this sequence. So, our first term again is B. Then we are going to skip letters, so C and D. And after D is E. And E now is our second term. Okay, let us continue. So, after E, we are going to skip another two letters again. So after E, we have F and G. And after G, we have H. And H now is our third term. And by using the third term, which is H, so we have to skip two letters again. So after H, we have I and J. Then K. Then K now is our fourth term. So the question now is, what is the next term after the letter K? So the next term after letter K is this one. So since the fourth term is K, then we are going to skip two letters again. So L and M, and next to M is N. That is why N is the next term after letter K. And the pattern again that we applied in this sequence is by skipping two letters after the preceding term. Remember that sequence have two most common types. And those are the what we call arithmetic sequence and geometric sequence. But for now, let us start with the what we call arithmetic sequence. So here, we are going to discuss how an arithmetic sequence formed, how can we able to determine the nth term of an arithmetic sequence, its sum, and its means. So I hope you are still with me. So let us continue this lesson. The question now is, what is an arithmetic sequence? So according to a source, an arithmetic sequence refers to a sequence in which any term is created by adding a constant number to the preceding term. And one important thing that you have to remember in dealing with arithmetic sequence is that the most common operation that we usually applied in this type of sequence are addition and subtraction. Again, the operation that we usually use in dealing with arithmetic sequence are addition and subtraction. And take note that the fixed number or the constant number that is being added is called common difference. And the formula of getting the common difference of a sequence is D equals A sub 2, which is our second term, minus A sub 1, which is our first term. So now, let us have some examples of arithmetic sequence. So for example number 1, we are going to prove that the sequence 3, 5, 7, 9 is an example of arithmetic sequence. And take note that we can only do that by checking if all the terms has a common difference. And again, for us to get the common difference, we are going to get the difference of each consecutive terms. Again, the formula in getting the common difference is D stands as the common difference equals A sub 2, which is our second term, minus A sub 1, which is our first term. So let us check. So for the first consecutive terms, we have the second term. We have the second term 5 minus the first term, which is 3. And its difference is 2. Next consecutive terms, we have 7 is as our third term minus the second term, which is 5. And their difference is 2. The next consecutive terms, we have 9 as our fourth term minus the third term, which is 7. And their difference is 2. So as you can see, the difference of all consecutive terms are of the same. So we have 2, we have 2, and also we have 2. And therefore, from these results, we prove that this is an example of arithmetic sequence since it has a common difference of 2. Let us have another one. So, for example number 2, just like what we did in example number 1, we are going to prove if this is an example of arithmetic sequence by checking its common difference. So, we have the second term, which is 8 minus the first term, which is 12, and their difference is negative 4. Again, operation of sign numbers. When we are subtracting two numbers with different signs, so 12 minus 8 is 4, and we all know that 12 is higher than 8 and its sign is negative. That is why our difference is negative 4. Next consecutive terms, we have 4 and 8. 4 as our third term minus our second term, which is 8. So 8 minus 4 again is 4, and 8 is higher than 4 and its sign is negative. That is why our difference is negative 4. Next consecutive terms, we have 0 and 4. 0 as our fourth term and 4 as our third term. So 0 minus 4 is just negative 4. So as you can see, the difference of all consecutive terms are also the same. So we have 8 minus 12 is negative 4, 4 minus 8 is negative 4, 0 minus 4 is negative 4. So, therefore, we prove that this is also an example of arithmetic sequence since it has a common difference which is negative 4. We have examples of arithmetic sequence. We also have examples of non-arithmetic sequence. So for example number 1, let us show why this sequence is not an example of arithmetic sequence. We have 2, 8, 14, and 19. So let us check whether it has a common difference or not. Okay, the second term, which is 8, minus the second term, which is 2. So the difference here is 6. Let's try to the next consecutive terms. We have 14 as our third term minus the second term, which is 8. And their difference is 6. Next consecutive terms, we have 19, our fourth term minus our third term, which is 14. And their difference is 5. So, as you can see, the difference of all consecutive terms are not of the same. We have 8 minus 2 is 6, 14 minus 8 is 6, and 19 minus 14 is 5, which is different from the difference of first two consecutive terms. And therefore, we can say that this sequence is not an example of arithmetic sequence since it has no common difference. Another example. Example number 2, we have the sequence 5, 9, 14, 18. So again, we have to check whether this sequence has a common difference or none. So the second term, we have 9 minus 5. 9 as our second term minus our first term, which is 5. So the difference is 4. Next consecutive term, we have 14 as our third term minus our second term, which is 9, and their difference is 5. And next consecutive term, we have our fourth term, which is 18, minus our third term, which is 14, and their difference is 4. So, just like in example number 1, as you can see, they have different common, they have different differences. So we have 4, 5, and 4. So therefore, we prove that this is also not an example of arithmetic sequences since it also has no common difference. Okay, let us now move on in finding the end term of an arithmetic sequence. The formula in getting the end term of an arithmetic sequence is defined as this. A sub n equals a sub 1 plus n minus 1 times the common difference d, wherein a sub 1 stands as our first term, n stands as the number of terms, and d stands as the common difference. Okay, now let us have an example of getting the end term of an arithmetic sequence. For example number 1, we are going to find the seventh term of the sequence 5, 9, 13, 17, 21. So the first step that we are going to perform is to find the given values. And from this sequence, we can see that the first term or a sub 1 is 5. And our common difference or d is 4. So why we come up with 4? Again, the formula of getting the common difference is a sub 2 minus a sub 1. And by substituting those values, we have a sub 2, our second term, which is 9, minus our first term, which is 5. And their difference is 9 minus 5 is just 4. And then our value of n is 7 since we are looking for the 7th term. Next thing to do is to use the formula of getting the nth term of the sequence. And the formula is a sub n equals a sub 1 plus n minus 1 times the common difference d. So, step 3 is all about substituting the given values to the formula. And these given values will be replaced in this formula. That is why we will have, so a sub n, so replace the value of n which is 7. That is why we have a sub 7 equals a sub 1 again is 5 plus n is 7 minus 1 times the common difference which is 4. So after substituting the given values, we can now simplify the expression inside the parentheses. And the expression inside the parentheses, we have 7 minus 1. And for that, we will have this expression, this equation now. So a sub 7 equals 5 plus, so the expression that we simplified, we have 7 minus 1 is just 6. Then copy the common difference, D. So after that, we can now multiply these numbers. So 6 times 4 is just 24. And our final answer for this will be 29, since 5 plus 24 is just 29. And from this result, we can say that the 7th term of the sequence is 29. Again, problem number 1 is find the 7th term of the sequence 5, 9, 13, 17, 21, 25. So here is the summarized step-by-step procedure of getting this 7th term. So again, use the formula in getting the nth term. We have a sub n equals a sub 1 plus n minus 1 times d. Next is substitute the given values by replacing those identified given. So we have a sub 7 equals 5 plus n 7 minus 1 times 4, which is our common difference. So after that, simplify the expression inside the parentheses. We have 7 minus 1, which is only equal to 6. Then 6 times 4 is 24. That is why the value of a sub 7 is 29, because 5 times 24 is just 29. And for us to check whether our answer is correct, so by using the first term and the common difference, we can easily check if our answer, which is a sub 7, is correct. So again, a sub 1 is 5 and the common difference is 4. And let us check by adding the common difference to the preceding terms. First, we have 5 as our first term. So we are just going to add the common difference 4 to the preceding terms. So 5, which is our first term, plus the common difference 4 equals 9. And 9 is our second term. Then next, 9 plus 4 equals 13, and 13 is our third term. Next, 13 plus the common difference 4 equals 17, and 17 is our fourth term. And 17 plus 4 equals 21, and 21 is our fifth term. Then next, 21 plus 4 equals 25. That is our sixth term. So again, we are looking for the seventh term. That is why we will continue it by 25 plus 4 equals 29, and 29 is our seventh term. So since we arrive at the seventh term with a value of 29, so therefore, the answer, our answer, which is a sub 7 equals 29, is correct. Okay, after we discuss the process of getting the nth term of an arithmetic sequence, let us now proceed to the sum of an arithmetic sequence. And the formula in getting the sum of an arithmetic sequence is given by this. So we have S sub n equals n all over by 2 multiply to 2 times a sub 1 plus n minus 1 times d, wherein our S stands as the sum, n stands as the number of terms, a sub 1 again stands as the first term, and d always stands as the common difference. Okay, now let us have an example of getting the sum of an arithmetic sequence. So, for example number 1, what is the sum of the arithmetic sequence 5, 9, 13, 17, 21 up until to the 10th term? So, the first step that we are going to do is to find the given values. So, the first is a sub 1. So, the a sub 1 for this given sequence is 5 or our first term. Next, d is 4 since 9 minus 5 is 4. Then, n is 10 since we are looking forward this sequence up until to the 10th term. So, we are going to find the sum of the arithmetic sequence until its 10th term. Next step to do is to use the formula in getting the sum of this arithmetic sequence. And the formula again is S sub n equals n over 2 multiplied to 2a sub 1 plus n minus 1 times d. There is a bracket here. Just assume na may bracket tayo dito. Step 3 is substitute the given data to the formula. These given values in this formula. So that is why we will have, so S sub n, replace the value of n which is 10 equals, n again is 10 over 2 times 2 multiply to the first term which is 5 plus n again is 10 minus 1 times the common difference which is 4. So after we substitute the given values to this formula, we can now simplify the expression inside the bracket. So may bracket tayo dito. So all these expressions, we have to simplify it first. So that is why we will have this one. So S sub 10 equals 10 over 2, 2 times 5 plus, okay, inside the parenthesis we have 10 minus 1. So inside the bracket, we also have parenthesis, and that is what we are going to simplify first. So 10 minus 1 is 9, then copy the common difference 4. Then after that, we can now simplify other terms inside the bracket. So 10 over 2, 2 times 5 is just 10, and 9 times 4 is 36. Then, simplify. Again, we will have S sub 10 equals 10 over 2. Add the expression inside the parentheses. We have 10 plus 36 is just 46. Then, simplify and get the quotient. So, in multiplying a fraction, take note, a fraction from a constant number, take note that we are just going to multiply the numerator to the constant number. And 10 times 46 is just 460. Then copy the denominator 2. And 460 divided by 2 will give us the final answer, which is S sub 10 equals 230. And from this result, we can say that the sum of the first 10th term of the sequence is 230. Again, our problem is what is the sum of the sequence 5, 9, 13, 17, 21 up until the 10th term. So here is the summarized step-by-step process that you are going to do when getting the sum of an arithmetic sequence. First is to use the formula, which is S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. Then after that, substitute the given values. So by replacing all those given values from based on the sequence, so we will have S sub 10 equals 10 over 2 times 2 times 5 plus 10 minus 1 times 4. Then after that, we simplify the expression inside the parentheses. We have 10 minus 1 is just 9. Then simplify the expression inside the bracket. We have 2 times, just disregard this number. So 2 times 5 is 10. This is not 56. This is just 5. So 2 times 5 is 10. Then 9 times 4 is 36. Then 10 over 2 times, okay, get the sum of these numbers. So 10 plus 36 is 46. And again, just like what I have said earlier, so when we are multiplying fraction to a whole number, just multiply the numerator and the whole number. So 46 times 10 is 460. Then just copy the denominator 2. Then it will give us the answer S sub 10 equals 230. Since if we divide 460 by 2, the resulting quotient is 230. So for us to check whether our answer is correct, what we are going to do is to list down all those numbers or all those terms from the first term up until the 10th term and get the sum of those 10 terms. So from this given sequence, as you can see, our first term is 5. And since our common difference here is 4, what we are going to do is just to add 4 to those preceding terms up until we arrive at our 10th term. So 5 plus 4, our common difference equals 9. And 9 is our second term. Next, add 4 to our second term. So 9 plus 4 equals 13. And 13 now is our third term. Next, 13 plus 14 equals 17. And 17 is our fourth term. Next, 17 plus 4 equals 21. And 21 is our fifth term. So since, based on our problem, we are going to get the sum of this sequence up until to the 10th term, so we are going to continue this process until we arrive at the 10th term. So 21 plus 4 equals 25, and 25 is our sixth term. 25 plus 4 equals 29, and 29 is our seventh term. 29 plus 4 equals 33, and 33 is our eighth term. Then 33 plus 4 equals 37, and 37 is our ninth term. 37 plus 41 plus 4 rather equals 41, and 41 is our 10th term. So now, we arrive at the 10th term. So let us go back to our problem. What is the sum of the arithmetic sequence 5, 9, 13, 17, 21 up until to the 10th term? So it only means that for us to get the sum of this sequence, we are going to get the sum of these terms. So from 5, we are going to add these numbers up until 41. And the sum of these numbers is this one. So 5 plus 9 is 14. Then 14 plus 13 is 27. And 27 plus 17 is 44. Then 44 plus 21 is 65. 65 plus 25 is 90. 90 plus 29 is 119. And 119 plus 33 is 152. 152 plus 37 is 189, and 189 plus 41 is 230. So we arrive at 230, which is the same as our answer for S sub 10, which is 230. So it only means that our answer is correct. Under arithmetic sequence, we also have to study the what we call arithmetic means. So what do we mean by arithmetic means? Okay, it is simply the terms included between any two consecutive terms of an arithmetic sequence. So in short, if we have three terms, the second term is the what we call arithmetic mean. And if we have four terms, the two middle terms will be our arithmetic means. Simply as that. And the formula in getting the arithmetic means is this one. A sub 2 equals A sub 1 plus A sub 3 all over by 2. Okay, let us have an example for arithmetic means. Example number 1, find the arithmetic mean between negative 10 and 26. So by using the formula which I discussed earlier, which is A sub 2 equals A sub 1 plus A sub 3 over 2, we will have to get the arithmetic mean between these numbers, which are negative 10 and 26. So first thing to do is to find the given values. And the given values are A sub 1 is negative 10. N is 3 since we are just looking for an arithmetic mean. Arithmetic mean means 1. So if we already have two terms which are negative 10 and 26, and we are just looking for an arithmetic mean, so it means that our n is just 3. And A sub 3, which our third term, is just 26. So after we identify the given values, we can now use the formula, which is A sub n equals A sub 1 plus A sub 3 all over by 2. So after we identify the given values and we rewrite the formula, we can now substitute the given values that we identified in step 1. So that is why we will have A sub 2 equals A sub 1 is negative 10 plus A sub 3 is 26 all over by 2. Step 4 here is to simplify the numerator using the rule of sign numbers. So as you can see, we still have to operate these numbers for us to get our final answer. And that is why we will have this 1. A sub 2 equals 16 over 2. So why do you think we come up with 16? The reason is because if two numbers have different signs, the operation to be used is subtraction. This is based on the rule of sign numbers. So if two numbers have different signs, the operation to be used is subtraction. So as you can see here, we have negative 10 and positive 26. So it is obvious that they have different signs, which are positive and negative. And based on the rule of sign, if two numbers have different sign, then we are going to subtract it. So 26 minus 10 is 16. And 26 is higher than 10 and its sign is positive. That is why the numerator is positive 16. So the final answer for this example is a sub 2 is 8. And that is why for arithmetic mean, for example number 1, the arithmetic mean between negative 10 and 26 is positive 8. Okay, let us have another example under arithmetic means. So for example number 2, our goal is to find two arithmetic means between 4 and 19. And we will be able to find those arithmetic means between these two numbers by applying the formula in getting the nth term. Okay, here are the step-by-step process for us to get those arithmetic means. First step is to find the given values. And the given values are a sub 1, here is 4, n is 4, since we already have two terms and we are looking for another two arithmetic means, that is why our n is 4. And a sub 4 here is 19. So after we identify the given values, we can now use the formula of getting the nth term, which is a sub n equals a sub 1 plus n minus 1 times d. So after that, we can now substitute the given values to this formula. That is why we will have a sub n again is 4 equals a sub 1 is 4 plus n is 4 minus 1 times d. So the value of d is still missing, so we are going to find it first for us to get those arithmetic means. So next, let us substitute those given values. So a sub 4 is 19 equals a sub 1 is 4 plus 4 minus 1 times d. So after that, we are going to simplify the operation inside the parentheses. So inside the parentheses, we have 4 minus 1. That is why we will have this equation. So 4 minus 1 is just 3. So next step to do is combine like terms by using transposition. So based on this equation, our like terms are 19 and 4 because they are both constant terms. So we are going to combine them, and the process of for us to combine those terms, we are going to apply or um, do the process of transposition. And from positive 4, if we are going to transpose this number to the other side, so it will become negative 4. That is why we will have 19 minus 4 equals 3d. So next thing to do is to operate the constant number, and 19 minus 4 is just 15 and equals to 3d. So divide both sides of the equation by, this is by 3. Again, this is 3, not 2. So we are going to divide both sides of the equation by 3, which is the numerical coefficient of d. So 15 over 3, 3d over 3. Then perform the cancellation. So 15 divided by 3 is just 5. Then cancel. The remaining term here will be d. So the value of d, or the common difference now, is 5. Okay, again, let us go back to our problem, which is find the arithmetic means between 4 and 19. And again, here is the step-by-step process that we performed earlier for us to get the value of the common difference. Okay, we apply the formula in getting the nth term, which is a sub n equals a sub 1 plus n minus 1 times d. Then we substitute the given values. So n is 4, a sub 1 is 4, n is 4. Then the value of this still missing. Then next, we substitute the given values. A sub 4 is 19 equals 4 plus 4 minus 1 times d. Then after that,
we simplify the expression inside the parentheses. So 4 minus 1 is 3. And then we combine like terms. And by doing that, we also apply the process of transposition. So from positive 4, we transpose the other side. It became negative 4. Then we operate the constant terms. 19 minus 4 is 15. And then after that, the variable d has still numerical coefficient. So we are going to delete this one. So to remove this numerical coefficient, we are going to divide both sides of the equation by 3, which is the numerical coefficient of d. So 15 divided by 3 is just 5. Then cancel the remaining variable. Here is d. So that is why we come up with the value of common difference, which is 5. And for us to check whether our answer is correct, we are just going to list those given terms and add this common difference until we arrive at our goal, which is to find the two arithmetic means between 4 and 19. So again, 4 is our first term. Again, so for us to check whether our answer is correct, so for us to check whether our answer is correct, so we are going to list all the given values and apply this value of common difference to those terms. So again, 4 is our first term, and for us to get the arithmetic means, we are just going to add this common difference to the first term and to the preceding terms. So 4 plus 5, so again, plus 5 is from our common difference is 9. 9 now is our second term. And 9 plus 5 is 14, and 14 now is our third term, and 14 plus 5 is 19, and 19 is our fourth term. So therefore, the two arithmetic means between 4 and 19 are 9 and 14. So it only means that our answer or the value of d that we identify, which is 5, is correct. Okay, just like what I have said earlier, there are two common types of sequences that you are going to encounter in this video, and those are arithmetic sequence and geometric sequence. So since I already discussed everything about arithmetic sequence, so let us now proceed with geometric sequence. So in our succeeding slides, we are going to discuss on how to get the nth term of a geometric sequence, how a geometric sequence form, how we can get the sum of geometric sequences, and how to get the geometric means. So I hope you are still with me, and let us continue these slides. Okay, the question now is, what is a geometric sequence? What do you think? How a geometric sequence form? Is it by adding a constant number to the preceding term? Is it by multiplying, or is it by dividing or subtracting? So let us know how a geometric sequence form. So according to a source, a geometric sequence is a set of integers in which each succeeding element is obtained by multiplying the previous term by a fixed number known as the common ratio, or in symbol small letter r. So just a short recall, just like what we discussed earlier, an arithmetic sequence is formed or obtained by adding. So, on the other hand, geometric sequence naman is obtained by multiplying a constant number to the preceding terms. Again, if we are going to compare these two types of sequences, arithmetic means is obtained by adding a constant term, while geometric sequence is obtained by multiplying a constant term to the preceding terms for us to get the succeeding terms. Let us have some examples of geometric sequence. Okay, example number 1, given the sequence 3, 6, 12, 24. So what are we going to do is just to prove that this sequence is an example of geometric sequence by determining whether it has a common ratio or not. So for us to get the common ratio, what we are going to do is just to divide the second term to the first term, the third term to the second term, and the fourth term to the third term. So that is why we will have 6 as the second term divided by the first term, which is 3. So the quotient here is 2. Then 12 divided by 6, 12 our third term divided by our second term, which is 6. So we'll have 2. And 24 divided by 12 will also give us 2. So since it has the same quotients, which is 2, so it only means that 3, 6, 12, 24 is a geometric sequence since it has a common ratio of 2. Another example, we have the sequence 2, negative 8, 32, and negative 128. So again, we are going to know if it has a common ratio or not. So let us know that by getting its ratio. So negative 8 divided by 2 is negative 4. Next, 32 divided by negative 8 is also negative 4. And negative 128 divided by 32 is also negative 4. So since it has the same quotients, we can say that the sequence 2, negative 8, 32, and negative 128 is a geometric sequence since it has a common ratio of negative 4. Okay, let us now discuss the nth term of a geometric sequence. So the nth term of a geometric sequence is defined as, okay, the formula is a sub n equals a sub 1 multiplied to r raised to n minus 1, wherein a sub 1 stands as our first term, a sub n is our last term, n is the number of terms, and r as the common ratio. Let us have an example in getting the nth term of a geometric sequence. Example number 1. Find the sixth term of the sequence 3, 15, 75, 375. Okay, first thing to do is to find the given or identify the given values. And the given values are a sub 1 is 3, r, which is the common ratio, is 5 because 15 divided by 3 is 5. 75 divided by 15 is 5. 375 divided by 75 is 5. That is why r is 5. And n is 6 since we are looking for the sixth term. So after we identify the given values, we can now use the formula of getting the nth term, which is a sub n equals a sub 1 times r raised to n minus 1. Then after that, after we identify the given values and use the formula, we can now substitute those given data in this formula. So that is why we will have a sub 6 equals 3 times 5 raised to 6 minus 1. So we are going to replace the value of n, which is 6. That is why we have a sub 6 equals a sub 1 as 3, then times r, which is 5, then raised to n minus 1, and is 6 minus 1. Next step is to simplify expression inside the parentheses. So inside the parentheses, we have the exponential form 5 raised to 6 minus 1. And what we are going to simplify first is the exponent, which is 6 minus 1. And 6 minus 1 is just 5. That is why we have a sub 6 equals 3 times 5 raised to 5. Then after that, simplify the exponential form, which is 5 raised to 5. And this means that we are going to multiply 5 by itself 5 times. So that is why we will have this one. So a sub 6, kinopya lang natin, equals, okay, a sub 6 equals 3. So multiply 5 by itself 5 times. So 5 times 5 times 5 times 5 times 5. So that is why we come up with this one. So 5 times 5 is 25. So dalawang 5 na iyon times another 5. So 125 times another 5 is 625 times 5 is 3,125. So ilang 5 yung multiply natin? So we have 1, 2, 3, 4, 5 because that is 5 raised to 5. So 5 raised to 5 is just equal to 3,125. That is why we'll have a sub 6 equals 3 times 3,125. And just like that, we are now going to operate the expression 3 times 3,125, and that will give us the answer 9,375. So, why we come up with 9,375? So, we multiplied 3 to 3,125. And therefore, we can conclude that the sixth term of the sequence is 9,375. So, after we discuss on how to get the nth term of a geometric sequence, let us now proceed in getting the sum of a geometric sequence. So, the formula in getting the sum of a geometric sequence is given by this. So, S sub n equals a sub 1 minus a sub 1 multiplied to r raised to n all over by 1 minus r, or just S sub n equals a sub 1 multiplied to 1 minus r raised to n all over by 1 minus r. Wherein S sub n stands as the sum, S sub n stands as the sum, a sub 1 as the first term, n as the number of terms, and r as the common ratio. So another formula that we can use in getting the sum of a geometric sequence is given by this. So S sub n equals a sub 1 minus r times a sub n all over by 1 minus r, wherein S sub n is also the sum, a sub n is the last term, and a sub 1 is the first term, and r stands as the common ratio. So let us have an example in getting the sum of a geometric sequence. Okay, example number 1. What is the sum of the geometric series 4, 12, 36, 108 to the 8th term? So our goal here is to find the sum of this sequence up until to the 8th term. So the first step that we are going to use is to find the given values. And the given values are a sub 1 is 4. A sub 1 is 4 as given in the sequence. And r is 3 since 12 divided by 4 is 3, 36 divided by 12 is 3, 108 divided by 36 is 3. That is why we come up with r is 3. And then n is 8 since the series is up until 8th term. So step 2 is use the formula in getting the sum, which is S sub n equals a sub 1 minus a sub 1 times r raised to n all over by 1 minus r. So the next step is substituting the given values to the formula. So S So again, replace the value of n, which is 8, and that is why we have sub s sub 8 equals a sub 1 is 4 minus a sub 1 again is 4, then times r is 3 raised to n, which is 8, then all over by 1 minus r again is 3. Then after we substitute the values to the given formula, we can now simplify the expression inside the parentheses. And the expression inside the parentheses, we have 3 raised to 8. So it only means that we are going to multiply 3 by itself 8 times. So that is why we will have this 1. So 1, 2, 3, 4, 5, 6, 7, 8. We are going to multiply 3 by itself 8 times. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Times 3 is 243. Times 3 again is 729. Multiply by 3 is 2,187. Then the product is 6,560. 1. That is why we will have this one. So S sub 8 equals 4 minus 4 times 6,561 all over by 1 minus 3. And after that, multiply 4 by 6,561 and this will give us 26,244. Next step is to simplify both the numerator and the denominator. So let us start with the numerator. So 26,244 minus 4 is 26,240. And 26,244 is higher than 4 or bigger than 4. That is why. And its sign is negative. That is why it's also negative. And in the denominator, 1 minus 3. So 3 minus 1 is 2 and 3 is higher than 1 and its sign is negative. That is why it is also negative. Last step is to get the quotient. So, negative 26,240 divided by negative 2 will give us the answer. S sub 8 equals positive 13,120. And this only means that the sum of the first 8 terms of the sequence is 13,120. Under the geometric sequence, we also have to study the what we call geometric means. So what do we mean by geometric means? And how can we able to solve for the geometric means of a sequence? And that is what we are going to discuss. So to solve for the geometric means of a given geometric sequence, the formula in getting the nth term is also used. And the formula in getting the nth term is given by this one. So a sub n is equal to a sub 1 multiplied to r raised to n minus 1. Okay, let us have an example for geometric mean. Example number 1, find the geometric mean between 4 and 144. Okay, step 1 is to identify the given values. And the given values are a sub 1 is 4, n is 3. Since we are just looking for a geometric mean, so we are looking for a 1 geometric mean, and we already have 2, so 2 plus 1 is 3, that is why n is 3. And then a sub n is 144. E sub n is 144. Then after that, after we identify the given values, we can now use the formula and get in the nth term of a geometric sequence, which is a sub n equals a sub 1 times r raised to n minus 1. Then next step is all about substituting the given values into this formula. That is why we will have a sub n is 144 equals 4 times r raised to 3 minus 1. So the value of r is still unknown, so we are going to get it first now. So simplify the expression inside the parentheses. So the exponent of r, we have 3 minus 1, and 3 minus 1 is just equal to 2. And after that, so multiply 4 by 3 squared, that is why we will have 144 equals 4 r squared. Next step is to divide both sides of the equation by 4. So, parang matira na lang dito is r squared, yung may variable na lamang. So, we are going to divide both sides of the equation by its coefficient, which is 4. That is why we will have this one. So, 144 divided by 4 equals 4r squared divided by 4. And after that, we're going to apply the cancellation. So, 144 divided by 4 will give us 36, and if we cancel this, so the remaining term here will only be r squared. Then step 6, get the square root of both sides of the equation. So the equation that we are pointing out is this one. So get the square root of 36 and get the square root of r squared. And the square root of 36 is just 6 because 6 times 6 is 36. So again, the meaning of square root is this one. So when you say square root, you are going to look for a number so that if you multiply 2 times by itself, the resulting product is the base, which is 36. That is why the number is 6. Then if you multiply it 2 times 6 times 6, the resulting product is 36. And then also get the square root of r squared. So r squared is r because r times r is just r squared. So there's always an invisible 1 here, and if you're going to add, so 1 plus 1 is 2, and just copy the variable r. So that is why it will give us the answer 6 equals r, or the value of common ratio is 6. So what does it mean? It only means that the geometric mean between 4 and 144 is 24. So why do you think we come up with 24? Because if we are going to base on this given number, so 4 is our first term and the common ratio is 6. So if we are going to multiply 4 by 6, the resulting product is 24. And then again, if we are going to multiply 24 by 6, the resulting product will be 144. That is why our answer, for example, number 1 is the geometric mean between 4 and 144 is 24. Before ending this video, let me share this verse coming from the book of Philippians chapter 4 verse 9. He says that whatever you have learned or received or heard from me or seen in me, put it into practice, and the God of peace will be with you. Thank you again for listening, and God bless everyone.